Okay, hi everyone. I hope you can hear me. I am Nur Husni. So I am going to show you how to use a sine bar to calculate angularity. Okay, so there are several ways to calculate angularity. So this is the sine bar method. Okay, yeah. So here we have several equipment that we use and several material also. Okay. Alright. So I'm gonna show you. So how we use the sine bar, okay? So right here we have the sine bar. So we have sine bar. We are going to use a trigonometry method, okay? So this is a trigonometry. Okay, let's say this is our product right there. Alright. So our product having 75 degree. Okay. So here we are going to have 75 degree also. Okay. So the length of this from here to here, we are having 100. Why 100? Because our sine bar is 100 mm. So that's why we get this 100. So the only one that we need to find is here, the height. We don't know what is the height. So we are using the sine. So the trigonometry method. So we have sine. Sine, or I always used to remember as so. So what this means is sine theta equal to O over H. Okay, sin theta equal to O over H. So it's equal to sine 75 equals to O, our O is H, over, so this one, okay, let me show you. This one is here, and the height is all the way up here. Okay, so this one H, and the other one is 100. Okay, so after we put the calculator on, we calculate this, we will get the height. So we get the height equal to 96.6. Okay, let me calculate that for a second. I need to check if it's correct. So sine 75 times 100. 96.6. Alright, so that's correct. So the height we get 96.6 mm. Okay, so we know already the height. Okay, so we are going to proceed to the next slide. Okay, here is the next slide. So the next slide. Okay, so what are we doing here now is to achieve. We are stacking the parallel bar to achieve the height that we want. So remember, the height that we want is 96.6. Okay, so back then we have drawn a triangle. So this is the triangle. Let me redraw. This is our triangle. Remember? So this is 100 and this is 75 degree. Okay. The height that we want to achieve from here to here is 96.6. Okay. This is the height that we want to achieve. Okay. So let me erase this for a second and we proceed to the video. Alright. After we already did this triangle, we get the height and we put our product. Okay, so the reason we put the product, the reason we do this triangle is actually to match the granite table. Okay, okay, so let me use this. So we do this to match this. So this two is parallel. Okay, the granite table and our product is on a parallelism. Okay, also if we want to calculate the angularity, we must do it on a granite table. Okay, so this is how we measure. We are measuring using the dial caliper, dial gauge. Okay,
Pusing kosong.
so basically, what are we doing here? What are we doing here? We take the dial caliper and push it in a little. We don't put it only above, but we push it in a little. After that, after that, we set the
Okay, dah pusing-pusing tu kau
uh,
gerakkan ke depan ke belakang.
gauge. We set the gauge to 0.
Kena pegang apa?
Yeah. So after that,
Okay.
we need to move front and back.
Sorry.
So you can see our part is moving, so need
Okay.
to hold.
Okay, okay, okay.
So
Cantik lah.
we
Oh,
are
cantik, cantik,
checking this
cantik.
front and back, front and back. So from the video, we see that the movement of the uh, meter is not very far. That means it is very in a good tolerance lah. Means it is 75. Okay.
Okay, hi, my name is Adam Daha. Okay, I will present about the step or procedure in using a profile projectile. Okay, profile projectile is used to display or to show the angle of the workpiece. So let's continue with the video. Okay, for commonly we have to power on the switch. Okay, for the machine. So in my friend hands, this one is used for the first step. We have to take this. Okay, DS has their own type. I will tell you about it in the later video. So this one is called overlay chart. Okay, so we have to put it in the profile projectile because we want to see or it will show the angle. Okay. Okay, let's continue for the next video. Okay, we have to put it the workpiece. We call it workpiece in the profile projectile. Okay, it's okay if not put it properly because this machine is adjustable. Okay, this one my friend to try to adjust the sharpening of the image. Okay, okay, the part that I said about adjustable. Okay, this one we can adjust the y-axis in order to get it upside or down. Okay, for this one, it is adjustable for the x-axis. As you can see, the workpiece display is display is going to the right. Okay. Okay. We use this because we want to get the straight line. We have to get the straight line in order to calculate the angle. Okay. We have to adjust it so the workpiece in a one straight line. Okay. Okay, let's continue with the next video. Okay, as you can see, as we moving this adjustable, so we want to get in the straight line, as I say straight line. So that's one. We get the 105 degree.
Nampak?
Okay, so for the below we get the 180. So we can calculate it with 180 minus 105 degree that we get. So the angle of workpiece that we get is 75 degree. Okay, so that's the step that we use in order to get the angle of the workpiece. Okay, because we don't see in the video, so we shown it the part or the type we use of the overlay chart, which is Mitutuyo number 11, with a part number is 512066. Okay. Okay, this is the result that we get from the profile projectile. Okay, so the angle is um, 75 degree. As we see, the 180 minus 105 degree. Okay, so this is the step that we use in order to get the angle of the workpiece using a profile projectile. Okay, thank you.